It's 9
Oh, wow.
OCX, so we're already late.
You can hear us? We are live. Okay.
And what did you have for breakfast?
Thank you for letting me know I am hot mic'd right now, Thaman, because I did not know. Yeah, this is weird because there's no speaker feedback.
No,
Yeah.
no.
Oh, okay. So we're going to start.
Yeah.
Good morning, everybody. My name's Steve Wally, and I'm here to talk today with. Okay, so that's really weird too. I'm here to talk with Shelley Lambert, one of my mentors in this grand experiment with students this year, as well as Maria Teresa Delgado from the Eclipse Foundation, who's been helping support all of the work that we've been doing. And so really briefly, my name's Stephen Wally. I work in the Azure office of the CTO for Microsoft. I work in the part of that is the open source ecosystem. And I'm also a lecturer at Carnegie Mellon University. And that's I'm adjunct faculty, but what that really means is I am a lowly paid instructor. Shelley, I'll let you introduce yourself.
Oh, sure. Hi, I'm Shelley Lambert, out of Ottawa, Canada. We've been working at the project Eclipse Adoptium for a long time, and we look forward to these opportunities that we get to work with students. And I'll hand it over to you.
Hi, I'm Maria Teresa, and I work for the Eclipse Foundation, and I guess I am the link between the teachers and the mentors, and in these kind of initiatives that we are trying to promote among our open source projects. So, back to you, Stephen.
Thanks. So the problem, I noticed, I've always violently disagreed with Mark Andreessen's idea that software is eating the world. To me, we are drowning in software. Most of it's mediocre, duplicative, and bad. And the reason I say that is if you kind of look at the Octoverse reporting out of how many GitHub repositories there are, this is almost an exponential growth in repositories kind of as they came up through and then were acquired by Microsoft. So we are drowning in stupid amounts of software. And the hard part is the real industry problem that I've been seeing is that there's a complete lack of understanding of open source moving into production. And you also end up with this lack of software engineering skill sets anymore. We're seeing a waning of that because we live in a world where anybody with a little bit of education can now be a net producer and publisher of software. And finally, the maintenance problem, the thing that's been, we've known about all the way back. I've got a 44-year career. Maintenance keeps getting worse, not better. And it's an accelerating problem. I joke with folks that software-transmitted disease is the new STD at this point. And the aha moment was about 5 years ago. I thought, could we build a course around this? Because well-run open source software projects are kind of natural labs for doing software engineering practice. And so what if we build an undergraduate course that was some basic software engineering theory, some basic open source hygiene, and then some intellectual property basics? Because again, like every artist, musician, photographer understands basic IP law as it pertains to their world. Software developers need to have that same understanding. And then if we kind of create student projects inside of active open source projects, that's where they can really get their hands dirty and begin to learn software engineering practice. And so Semesters of Code is born. I started it at Johns Hopkins University, and we ran 2 iterations of the class there, and it was an in-semester normal course. We ran it in fall of 2021, and that was the first time after the start of the pandemic that students were coming back to campus, so everything was run. There was still kind of an active Zoom feed in all of the classes. We ran it again in 2022. And to size those student projects, this is where the big lift came. Because I'm walking into it naively thinking, I've been in industry for a long time, I get up and give talks all the time. This is just like giving a talk, only it's going to be 22 talks over the course of a semester, kind of with some regularity. And I was practicing my timing for slides and all of those kinds of things. But the real meat of it is these open source projects. And so through the 2 classes, we had 5 projects the first time, 7 the second time. And we were trying to, my ask of my mentors in those projects was I need 2 mentors, and please define 5 student-sized projects. And we kind of figured if we treated it as the 4 hours, 5 hours a week of lab time, you'd end up in a world where you had about 50 to 70 hours of student work. Remember, they still got to come up a learning curve, but that was kind of the sizing of all of this. That 2 mentors per open source project proved to be really valuable. We suggested it as a resilience thing, but in that first iteration of the class, I lost 2 to job changes kind of midway through. So resilience was important. What was new the second time we did it is we doubled. We went from 20 students to 40 students, but the second 20, we still had an active Zoom feed, so they were actually at the University of Galway in Ireland. It was an afternoon class for them. It was a morning class in Baltimore at Johns Hopkins. I had administrative support at the university. This was the first time we started playing with this idea of collaborating in the same project, but still not quite collaborating together. And we were moving to a more active learning style. And when I talk about learning style and pedagogy, I'm married to a school teacher. So before the first class, she beat basic pedagogy into me of how to think about organizing the classroom. So I at least wasn't walking in completely cold. But as I went through this, I quickly discovered Jean Lave's work. And Jean Lave's work is this idea that all learning is social learning. She's an anthropologist, and she did an enormous amount of work around apprenticeship and mentorship and this idea of legitimate peripheral participation. It's a legitimate learning opportunity. You're part of the outside group, learning your way inside the group, so it's peripheral. You're on the peripheral. And it's participative. You're doing something to learn something. The other thing I discovered, there's a Nobel laureate in physics named Carl Wieman. He teaches at Stanford, and what they realized about 20 years ago is the undergraduate class moving into graduate studies seemed to know nothing of physics, even though they'd just been taught physics by this Nobel laureate and the rest of his team. And so, being good physicists, they did experiments on the students to try and figure out what's going on here. And what they realized was it's not about you as a teacher entertaining students at the front of the room, imparting knowledge to them. It really is this active way of learning. So what they ended up doing is they would give students the reading the night before, and then in class, they basically force them into teams of 4 or 5, and from there, they'd present them problems to solve, and then they'd just kind of circulate amongst the teams of students, nudging them along to get them past the hard part. Because the students were able to mentor each other up that learning curve better than a Nobel laureate at the front of the room. And like the measurements they were doing on this, it moved the whole bell curve of their success rates to the right. In the first 2 iterations, though, we realized we have a problem. It's going to scale badly. I can't be in multiple universities at once. The other problem, the mentors were noticing that the students are struggling. The idea that we got 60 students through their open source projects in these larger open source projects amazed us, because some of them were struggling hard. And they're all working 70 to 80 hours a week, but remember, they've got 4 or 5 other courses banging for their attention. We ended up, summer of 2023, we moved to Carnegie Mellon University. Downturn in the economy's hit. Students have lost their internships. And Carnegie Mellon wants to kind of recreate this world so that there's an internship course available to them. They co-teach, so all of a sudden I get to be in a room with a real professor who knows what they're doing in terms of teaching. And the interesting thing here is he demanded that we force the students into teams of 4 or 5. Mm-hmm. And this time, we don't have maybe 70, 80 hours over the term. We've got 40 hours a week for most of the students, 20 hours for a few that had other commitments. It's still 2 mentors per project, but now we have big, meaty projects. And my co-presenters will tell you about that in a moment, but this is no longer, hi, I need a small project for a student to do. This is now, these teams of students are going to tackle big work inside of these real-world software systems. We were doing lots of curriculum tuning along the way, and we would also act as kind of coaches on the outside of this. So the students, as a team, had 2 mentors plus us as coaches. And we were forcing them to, the other thing he really wanted was the students to get used to that how much communications really goes on in software engineering. So we were forcing them to present to the class regularly throughout that summer. Outrageously better learning outcomes for these students. And the thing that was really shocking is without any cueing from us at the front of the classroom, they end up coming up these learning curves, mentoring one another up these complex learning curves into real software experience, as well as what they were getting from their mentors to actually tackle the big work. Student confidence, you can watch them kind of thing, presentation to final presentation, just gaining confidence as speakers. And this again, there was that really interesting psychological thing you start to see. There's a lot of us that are a little bit neurodiverse in this industry. We gravitate here. You can watch students that are very introverted. I am a high-functioning introvert, so I know what this means. That are gaining confidence as they come through because they're being forced to communicate with each other on a daily basis, their mentors multiple times per week, coaches once a week, and then presenting back out to the class, and everybody's required to present. And so you can watch every single one of them get better and better through the year. It was just an amazing outcome. There's a link at the bottom there too. One of the students, they posted their final presentation to the class. So to give you an idea of the work they undertook and just how the students were presenting as a team by the end of the summer. And so I'm going to turn it over now to Maria Teresa to talk about, kind of the Eclipse Foundation's engagement in all of this.
Yeah, thank you. Thank you, Stephen. I'm going to be very brief. I'm going to tell you how we participate to these kind of initiatives that people like Stephen bring to the Eclipse Foundation. And I gave this a little bit of thought because we don't actually do the mentoring part, and the program is coming from Stephen. But what do we have that makes these kind of programs work? And I think what we bring to the table is the open source rules of engagement, right? This is one of the guiding principles of the Eclipse Foundation, and these are 3 ideas that as a committer from an Eclipse project you might be familiar with. And those are openness, transparency, and meritocracy. These are kind of the rules that govern our projects, and these are kind of the rules that govern us and the way we communicate and we interact with Stephen, educators, and organizations like the one that Shelley represents, right? So the idea is that by being open, we level the playing field for anyone, any participant, so they can contribute equally to a project. These encourage collaboration, these encourage sharing the knowledge, again, around a particular project, and it fosters a community that is welcoming to anyone. We also are based on transparency, which means that everything that is happening on an open source project happens publicly, so it's available for everyone and anyone to see and to join. This promotes accountability and trust among the parties that are involved, and all the stakeholders have access to information at all times and to the decisions that are taken within a project. Finally, one of these 3 rules of engagement is the meritocracy, and this is great also for these kind of schemes, because contributions are recognized based on merit. So this means that even as a student, you can come around and contribute, and you will be recognized by your work. It doesn't really matter who you work with, who you're affiliated with. It's just the most capable individuals gain leadership and important roles within our community. So we kind of translated that into the students, and it's the same. So openness fosters collaborations among the students. Meritocracy kind of rewards people that contribute more and better. And transparency actually allows everyone to just walk in and have access to pretty much anything that happens in the projects. These rules also apply to us and the way we communicate these initiatives to the Eclipse Foundation projects. Basically what we've done with this kind of project like Semester of Codes and Google Summer of Code is we We do call for projects. We send all the information we have to our projects, and we do a call for participation. So we define minimum bare requirements, like Stephen said, like having 2 mentors, having a project idea that's open enough for a group of students to work on. And then together with the people that are promoting these initiatives, we decide which of these projects, actually based on merit from that project, are a good match with students. And everything is happening in the open. We're using issues to track the way these ideas are proposed, the way that students express their interest in them. So I guess that the main message that I want to share with you here is that as a foundation, we exist because of these open source rules of engagement. And this is great for these kind of initiatives in education. And it translates very good into programs like this, where students just come from an outside world to the Eclipse Foundation projects, and they can just walk right in. And this is all thank you to the transparency, openness, and meritocracy rules of engagement that we apply every day in our projects and our life. That's pretty much all that I wanted to share. I'm going to give it to Shelley now.
All right, thank you.
Go ahead.
Yeah, and by the way, the mentorship experience is very deep and dirty, if you will, compared to the high and mighty, open, transparent meritocracy beliefs in that sense. I have to say I'm 100% in agreement and excited to be working with both Maria Teresa and Steph, because they bring to us these wonderful opportunities where we can do better in our projects. And I'm going to talk really briefly about some of this stuff. So when I say it's kind of down and dirty, we're the people that, mentors on these kinds of projects are the people that work directly with students several times a week. It's our responsibility, or I see it as our responsibility, to ensure students are successful. And if that means, it starts with picking what's the right project to propose to one of these programs. We don't pick projects that we personally wouldn't want to do. We pick the juiciest, most interesting projects for students to select from, because we want them to be excited about coming to our projects and working on them. So the way we actually have, so I work mostly at Eclipse Adoptium. There are a lot of sub-projects underneath of that kind of top-level project. One of them is called Eclipse Aquavit. And there's no end to the amount of really cool, amazing features that we can be creating within that project. So we actually have a wish list of these features that we wish we could do, we wish we could get to, really find interesting, and we possibly have prototyped them as well, but we've never been able to find time out of the very rigorous release schedule for our products where we can set aside and dedicate uninterrupted time to make these real and productize these ideas. So in comes this idea of semesters of code and a group of students who might join us. So we select out of that wish list, and we made 2 proposals this year, and both proposals were selected. We were very excited about that. The other thing I'll say, as kind of a person who organizes this kind of work in our projects, I also select from that wish list so that I give other people in our projects mentorship experience. So when possible, we have a range of people mentoring from our project. And we actually do more than the minimum 2 mentors, trying to do 3 or 4 per project. In that way, we have not only redundancy, but for people who have never mentored before, they can shadow or join the project as well and learn and see from other more experienced mentors, because we actually have mentored a lot in several different open source projects. It's the only way we can get extra hands helping at the project usually. Giving people a chance to work on the coolest stuff is where we start with this. And I'll say, why do we like student programs like Semesters of Code? And there was an equivalent one similar to this called CanOSP for a while in Canada, where I'm based out of. We actually really like these programs because, as opposed to some other programs we've participated in, students are coming in at a certain level of knowledge already. So they know how to use Git. They know certain things that in other programs we have to start really from scratch, which is a lot of heavy lifting for mentors. I'll say, well, can be very satisfying. We also have to meter our time and energy. When you start with a program like this, a group of students, you're getting to meet with them and talk to them as a group. So there's that notion of cheaper by the dozen, if you will, where instead of talking to an individual and then separately talking to another individual, your time is optimized. You're talking to 4 or 5 students in a group. You're sharing your expertise on a particular problem set. You're getting to answer questions. They spend some time teaching each other as well. So really you're multiplying the potential of your time across a whole bunch of people. So instead of 1 set of hands helping, you might have 5 set of hands helping, and you've only invested X amount of hours a week. So that's really fantastic. But I guess the thing I most like about these programs is the enthusiasm that students bring to a project and their fresh perspective. So when you ever have to teach something about the work you do, it's wonderful to be able to do that to kind of bright, fresh eyes, because they're going to ask you questions and you're going to go, oh, yeah, we should have thought about that. If you're finding that, okay, first of all, we all know documentation is never sufficient. If you're finding that you're getting a lot of questions in a certain area, you can kind of learn and grow from that. But I will say that for me personally, having a group of students come in to work in the area that I spend most of my time working on is extremely energizing. It's just wonderful to see. And we did have groups of students. Both projects were a real blend of different personalities, and it was just really satisfying this past term that we worked with them. But I will say finally, for me, what are the benefits, the number one benefits of mentoring? One, we get to usher in these new features. And I don't know if we won't talk about it too much. I do have a talk about one of the 2 projects we worked with, Semesters of Code, later today. But these 2 projects we worked on wouldn't have been possible without the help of the energetic students that came to work with us for an entire 4 months. So again, iterating that this isn't just a dabble. Students are actually committed. What we hope happens with spending time and mentoring over the course of a term is that students will want to come back and work on the project later, or they'll tell their friends, here's some good opportunity to work in an open source project, to be seen, to have those contributions visible to employers when you go out in the workforce and want to show off what you can do. So it's kind of one of the best ways to interview people as well. I'll say, if you want to know whether or not this is a person you'd want to bring in full time into your companies or into your projects, 4 months in one of these terms is a fantastic way to know what someone's capable of, not just in terms of technical skills, but in their way that they communicate and in the way that they can work as a team. So I think I'll pass it back to you. Thank you.
Thanks, folks. And so I'll try and bring this all home. The idea of why is this exciting to me, like the thing that continues to drive me here, This gentleman's Peter Nauer. This is the Nauer of Backus-Nauer format, if you're a compiler person. Nauer wrote this paper called Programming as Theory Building back in '85. And I got subjected to this paper about 8 years ago. And it's a hard read. But the thing that's shocking, he walks into this idea of why is maintenance hard? And he's at the end of his career at this point, and he's worked on some of the big early projects in software construction out there. He's done compilers, he's done operating systems, and maintenance is hard. And he builds on this idea that a program is an exercise in theory building. Every program has a theory at the heart of it. And the programmers that build the program hold that theory. And it's really, holding that theory in your head, they are the best people to be able to evolve that software. And because you understand the theory of the program, when new requirements come in, you can understand what has to change, how the theory has to evolve around that software. And the consequences, if Nauer's right, we live with these consequences all around us all the time. We are constantly seeing that tension in documentation versus document. You can't trust the documentation, it's never up to date. We see this in comment your program, except comments are never up to date. We've also seen that though in entire systems of programming. Knuth's literate programming from back in the 90s was an amazing system to try and present the theory of a program. We've seen all the work in formal methods all the way back through the 90s with Z notation and VDM and TLA+. And again, this is all this idea of trying to build a representational theory of the program. And even when you start thinking about test-driven development, that is a restatement of the program and its theory as test assertions before you write the program. So this is constant. And the aha for Nauer is if you don't understand the theory of the program, the changes will create debt. And you will continue to end up in the place until the program becomes unmaintainable. And we've all seen that. Nauer's solution that he kind of comes to at the end of the paper is this idea of the only way to solve for this problem is to actually mentor new people in. It's all of Lave's legitimate peripheral participation work again. You need to mentor them in. The students need to be doing relevant things in the context of the program for them to become competent in the theory of the program. And so this is kind of leading me down this path of, it's not just that all learning is social learning. I'm a firm believer at this point of all software is social software. And when you start considering the way our projects work in the open source world, but also you think of any large project you've worked on, we can document all of the process for how we make decisions. But the reality of it is it's a practice. It is this constant practice of how we do things together. And so the documentation is important, but almost irrelevant to the practice that continues to carry that social thread through the life of the software. I teach programming teams, product teams, how to think about this all the time in terms of how to engage with open source projects in your product space. And I'm always walking them through this idea of how do you encourage people to use the project, how do you encourage developers to get to a point, how do you encourage those developers to become contributors. But really, I could just as easily be saying, how do you teach and mentor those folks into it? Because that's the reality of what you have to do when you really see projects that do this well, or product teams that are inventing open source that do this well. And I set up these frameworks, and it's always across these kind of three groups of engineering practice, open source community practice, and then nonprofits are a separate skill set. But you have to mentor folks into that as well. You don't walk into one of these things, and I'm now sitting on the governing board of this nonprofit thing. You don't know what the job is until you've been mentored into it. And I talk for a long time now, kind of this is the personal aha for me, is I've talked about these things as activities for a long time, trying to, yes, you have to get good at these activities. But the reality is, as I'm starting, what I'm learning from teaching students is that actually you have to mentor people into these activities in the real world as well. So we are all students all the time. The project is, the experiments are continuing. I am still running these as university classes. I'll be bothering these two fine co-presenters again because next summer is coming. But at the same time, I'm also looking at, we're trying to do something non-traditional Western university style with a boot camp. probably through CMU of Africa. And I actually want to bring this inside of Microsoft right now. Microsoft processes 2,000 interns every summer. And I want to start playing with that as a methodology of upskilling their software engineering background. But also, we're all concerned right now in the industry around software security. And I have a captive audience of interns that we can start to layer secure software programming techniques onto in the educational side of this. So I think there's lots of new and interesting things to be happening here. And with that, that's the talk from us today. And I think we've got 3 minutes for questions if somebody has a quick question, or you can find us outside afterwards. Thank you very much.
Thank you.
Hey, we survived. And I have no idea how the transitions happen here, because we were the first people up.
That's
so
right.
We're going to gently walk
question.
off this. Oh,
Okay.
of course there's a question.
The microphone is coming.
Can you hear me?
Oh, we have a...
Hi. Yeah, one question. You mentioned that you transitioned from the initial program where you had students doing 20, 40 hours for a semester to students doing 40 hours a week.
Yep.
And bizarrely, the results went up. Is it not just a time factor there?
So perfect question. The interesting thing, though, that happened there was the work got more complex. So I think the outcomes, it's not just that they have more time, it's they now have sufficient time that you can tackle a big piece of work. The kind of work they were doing in those first 2 iterations, these were small projects. They spent half the time coming up the tool chain, and then they had a very small amount of time to get work done. Whereas here, they've got more time to mentor each other up the tool chain, so it happens faster, and they can get to the meat of this big complex work. One of the pieces we did with an OpenStack project, let's see if I can do this quickly. The nature of the project was you were using OpenStack to stand up a Kubernetes cluster, and they were retooling all of the error messages in a particular piece of that code. And none of them knew what a container was on day one. And so the idea that they had to come up the container learning curve, the Kubernetes learning curve, and then the OpenStack learning curve, they were getting panicked because they were at like week 9 and they still hadn't written any code. But they'd come up this massive learning curve, and they had like Kubernetes and OpenStack all over their resume as graduating students now. And so it was just the nature of the work was so much deeper because they had the extra time. And so it kind of goes hand in hand.
And I would add that mentors don't want to work in a scenario where the outcomes are small. So if you don't have that dedicated time, you can't take on big pieces of work. So why would you? So this is just a much better program for us.
And one of the things that Shelley pointed out to me back in the summer while this was still going on that I thought was fascinating was the idea that, like, we're all familiar in our product realms of, there's always those features below the cut line from a budgetary point of view in regular planning. But that happens in big open source projects as well. And it's really what Shelley was talking about. There is a long list of important work that these professionals that might be employed in different companies, and they spend 40 hours a week on that work, on that project. But there's still a long list of things they really want to tackle that they don't have time for. And this is a way to tackle big work. So everybody wins on this.
Yeah.
Thanks very much.
Thank you.